Welcome everybody to the September virtual community meetup. Let me share my screen. Today I'm going to go over the upcoming events we have, and then we're going to do an interview with Rob Holland, and then I'll attempt to recap our replay conference. So for upcoming events, we can see on temporal.io/community the map with the events, and then we're going to GopherCon this week, and we're doing a meetup in San Diego along with that. The next week, we're going to QCon and SF. And then we are sponsoring All Things Open, and I'll be giving a talk there in Raleigh mid-October. Then we have meetups in London and Paris, and then also and we'll have a booth at PyCon Sweden. Then we also have a couple of meetups coming up in New York that we don't have up here yet. One is on the 25th. That'll probably be at Datadog's office in Manhattan. And then another one in November with the Python user group that we will announce later once we have more information. All right, starting up with Rob Holland. I will share now. So welcome, Rob.
Hey.
Rob is a technologist at Temporal and has worked on a lot of different things here. And I wanted to interview him just to share like a window into a temporal light or whatever, or temporal worker, whatever we're calling ourselves as employees, and learn about him and his background and stuff he's working on. So Rob, I'm curious, could you give like a brief overview of your career in tech so far?
Yeah, sure. So started out as a sysadmin at Internet Exchange Point in London, and slight baptism of fire, whereby my manager and his manager and his manager and the CEO of the company all left to start a competitor. So into the deep end, all of my sort of the remaining people asking me to do all these things that I'd never done before, which was terrifying, but also great. Learned so much and decided that this was definitely what I want to be doing. Really enjoyed all the I'm just telling my audio's cooking up. Hang on a sec.
No worries.
Switching to a wired connection. So hard to tell with just one sentence, I guess. Let me know if it doesn't improve. I can try turning off Wi-Fi and see if that helps. If it doesn't get there. Cool. Okay, yeah. So learned that, decided this was definitely what I wanted to be doing. So sort of got into it as a hobby as well as just work. Started working with a Linux distribution, which is gaining a lot of Gen2 Linux. Got involved as a contributor and worked on their infrastructure team as well, so handling their server infrastructure and things like that. Was lucky enough to be headhunted by Google, and then spent some time working at Google, about a year and a half working at Google. Loved the people, but didn't really get on with the structure of the place. It was too big, I felt, for me to sort of be as productive as I wanted to be, so to speak. So started a company with a friend of mine doing some security consultancy for a while, and then ended up co-founding Clearbit, you may have heard of, which is a company run by Alex McCall. It's run by Alex McCall, doing enrichment on data and stuff. Loads of fascinating engineering challenges I really got my teeth into at Clearbit. Had no real love for the product itself, like it's solved the problem I'd never really had, and it wasn't a sort of naturally passionate business for me. So decided I probably wanted to move on from there. At the time, Alex came across Temporal kind of by accident. and said that it might be something that I'd be interested in, having been the one at Clibit who designed the infrastructure most of the time, and sort of taken us through the generations of things like Kubernetes became a thing. I just thought that Temporal would be of interest to me, so I started playing around with it. I wish we'd had it when we started Clibit, because it saved so many problems with things like duplicate requests coming in and a lot of other stuff that sort of Temporal just sort of fixes out of the box, where it's very easy to do things like singletons. But yeah, I decided that Temporal was going to be it. So I started working on the Ruby SDK, provided by Coinbase at the time, community SDK. And just from there, just fell in love with Temporal. So continued hacking on that and contributing, and then got more involved and started chatting to Ryland a lot, and eventually hired as a contractor by Temporal to help work on the encryption side of things, the sort of browser flow and that kind of thing, the design of the network architecture to make sure that security could be done in a way where Temporal never had to see any of the unencrypted data. And then became a full-time employee about 3 months after that, I think. And that's where we are now.
When was that? What number of employee were you?
So I like to think I was 20 because that was when I was hired full-time as a contractor, but doesn't actually really count. So technically I'm like 40, I think, because of the contracting period. But still fairly early in the grand scheme of things.
2021?
Yes, I believe so.
Cool. I'm curious, like there's a fun story about how you wound up being hired as a contractor. Could you share that?
I guess the short version is I was really, really annoying. I started contributing to all this, the Coinbase SDK. I really wanted to sort of get involved in Temporal, but wasn't sure, realistically, if they'd ever be able to hire me because I was remote and they weren't really doing remote at the time and all this kind of stuff. So I thought, well, if I can't get hired by Temporal, I definitely want to work with Temporal. So, what can I do? So I thought, I know, I could start a hosted offering for Temporal. I thought, that would be a great idea. That would definitely make some money. So I mentioned this to Ryland, and he's like, yeah, I'd kind of rather you didn't do that. Thankfully, later we managed to figure out how they could hire me. Yeah, it was an interesting idea to float to them at the time, because obviously that was what I had every intention of doing, but I just didn't realize it at the time.
Like they hadn't announced cloud and it wasn't available, so we're like, oh,
yeah, this was a while before the public announcement. Yeah.
Right. Cool. So I think you said in terms of like projects you've worked on at Temporal, you started out working on the UI v1, like the old UI. Is that right? Or is this?
Specifically, it was wiring in support so that we could handle encryption in the web UI. There were several ideas floating around at the time. We weren't really sure where to go. Like we might have, there was talk about building a browser extension or something like that under the encryption. Managed to find a way to sort of route the encryption traffic through the TCTL command, the command line tool from Temporal, running on the developer's laptop so that we didn't have to leak any of the traffic across other networks or off the developer's machine or anything. So that worked out well as sort of the version 1 of all this architecture. And later on, I went to lead on the project to develop the codec system that we have now. So payload codecs, remote codec server, and that kind of stuff, alongside all the fantastic engineers, Chad and Tiho and their engineering team. So very all these amazing people.
Okay, so before that stuff, when I looked at the UI and I was using an encryption payload converter or codec, I couldn't see anything because it was just right. Or like
yes, exactly. Okay. Yeah. So the UI had no way to decrypt the traffic. So if you're using encryption as a data converter, then the UI would just show you the encrypted payload, and there would be no way for you to decrypt that. The same when you're using TCTL. So any system that was using encryption, the developer experience was not great because there was no way for developers to realistically get up out without sort of copying and pasting stuff into some kind of homebrewed command line tool that they might have made or something along those lines. So it's improving the developer experience. And then again, sort of the second iteration on this was more towards the operator experience rather than developer experience. So moving key management and stuff into a centralized place on the on the users or customers' servers, so that still there's no need for any of the plain text traffic to ever reach Temporal.
So the first version was like a plugin for TCTL, where you write some Go code, is that right? And then TCTL only when you're working on localhost for the UI can you use this plugin. Was that right?
Yeah. So so the web UI can be hosted anywhere because WebSockets are allowed to connect to localhost. The TCTL command would open up a localhost port with the WebSocket thing, but all of the developers would have to have the same port being used.
Right.
But we did add an override per developer. But yeah, you'd have to compile some Go code. There was no way to use languages other than Go. And the interface for the plugins, which is based on HashiCorp's plugin code for Go, was brittle. And it wasn't obvious to us at the time, but obvious to me, I should say. But it wouldn't allow us to actually add encryption further down the line. So if you wanted to start workflows, as opposed to just like list workflows and see what state they're in, there was not going to be a way for us to pass the data over the plugin interface in a way that the Go plugin could perform the encryption. So it was great for reading, it worked fine there, but we couldn't reverse that to actually start workflows with encrypted traffic. So that was one of the reasons that we moved on to the codec server architecture and payload, which actually allow us to do it. And they don't need plugins anymore because the interface is standardized. And you can write the codec server in any language you choose.
And you also don't need to host it on your own machine, so you don't need to know the keys. Like every developer doesn't need to have it. Okay, cool.
Yeah, correct. So it's much easier to centrally manage.
What things were after encryption stuff in terms of your work at Temporal?
Yeah, so I've done a couple of things. I've moved around quite a lot. So one of the things I worked on along with Tom Wheeler and co from the documentation team and education teams was the background checks application, which was an example application.
Sorry, I can't hear. You said the background check application?
Yeah, which was like a mini version of Checker, for those of you familiar with it, which is a background check service online. So it was a real application. People could read through the code and see, how we suggest you use temporal primitives. Obviously, the actual interfaces were faked out in terms of fetching data and that kind of thing, but it allowed you to see how you might run a workflow that parallelizes activities and sort of uses child workflows and that kind of thing, signals. So one of the workflows, if you pardon the expression, was something that required some human interaction. So there'd be a criminal background check, which was to be performed by like a court clerk. So they'd have to go and look up the records and then signal that they've done the background check. So there's kind of use cases there that people could learn from. And then the docs team and education team added loads of structure around this to sort of help people find a nice way through to sort of learn as they go at a nice pace and sort of really build it out as something that people can kind of either go in as a reference to say, oh, I really want to know how to do this, and sort of drill in straight away to this thing they're interested in, like signals, for example, or have like a more guided, narrated kind of tour through the code to sort of get a more general feel for how applications might be built and tied together. And it had some small UI and sort of email interactions and things of that nature as well. So to give a bit more of a realistic feel to it.
Yeah, I think that's a common user request we get is folks wanting to see more real, larger sample applications versus most of our like sample repos, like samples dash go, etc., are mainly focused on like a single feature of the SDK. So it's cool that we have at least one big one and hopefully more in the future, and hopefully more languages as well.
Yeah, more languages would definitely be really good, especially because Temporal is polyglot. It's nice to try and allow people to dig into the language which is best for the specific task they have in mind. So, ad hoc languages for activities potentially, if they're doing something that's numerical analysis, for example, people often go to Python, whereas they might want to build their workflows in Go or Java. So kind of allowing people to mix and match and making sure we've got a variety of samples for people to learn from different languages.
Yeah, it'd also be cool to see a major application in a few different languages. So if I know both, if I know multiple, I can decide like which one uh, looks the best, I guess, or which one I want to use most. Um,
Yeah.
what's next after that?
So I've done some benchmark testing as well to try and figure out how hard you can push, various Postgres and MySQL instances and that kind of thing, which I hope to continue in the future as well. Sort of find like where the level is that you need to start thinking about Cassandra, for example, and other similar things. I think next will probably be more applications along the lines of background checks to help people learn, especially now we're bringing out new features like was announced at Replay, where we have this update feature, which is a much nicer way to handle a lot of the use cases where previously you have to do signals and queries, sort of synchronous updates. So yeah, I think definitely some more real feeling application code for people to learn from and dig in and figure out how they can apply the use cases and patterns that they have to these applications, and sort of try and take as much from those sort of pre-written stuff as they can. And one of the things that we've historically not done the best job at is sort of communicating the best practices that we feel are the best way to use Temporal, and also those that we hear from our users and customers that they're finding really useful in their work. We don't tend to sort of offer those up for others to learn from as well as we should. So I'd really like to try and push those to the forefront, and allow others to learn more quickly and sort of soak this kind of knowledge up to get off the ground quicker, but also to sort of improve the designs of their existing systems as well for those that are already using Temporal.
Yeah, I know solutions architect Peter has like an internal doc on workflow design, like architecture kind of stuff, and I'd like to work on making that like a public resource that we can share. But for now, sign up for Cloud and then get your own Peter with lots of internal knowledge to help design your workflows. So going back to the benchmark testing. So you're talking about having some setup of deployed temporal cluster with one of the databases you mentioned. And the cluster is a certain size. So like there's a certain number of, so there's different services in the cluster, like the front end and the history and the matching. And there's each of those is like a different number of pods and a different size pod. And then the benchmarking is like running workflows against the server, like at a certain rate to see its performance, like what kind of latency you get, what kind of metrics happen. Is that benchmarking in a nutshell? And then what's the purpose of benchmarking?
So as you say, I guess the elephant in the room, so to speak, is the fact that it's very difficult to change the number of history shards in Temporal after, which is to say, once you build a cluster, you can't change this number. And the number is really important in terms of performance. So yeah, the benchmarking project has primarily been so far about trying to help people who are coming into Temporal figure out how hard they need to push Temporal. So how many state transitions, as we call them, they need to get through to support the workload that they want to run. And then try and give them a guide as to how big a database instance they need to support that work. So to do that, in tuning the number of pods for the various Temporal services and the number of poll accounts on the workers and all these kind of things that come into optimizing a Temporal system to get the best possible performance we can out of a given database instance. So like one of the IDS instance sizes, for example, or Aurora, the GCP hosted databases. And use that to sort of produce what kind of latency you can expect. So applications are often very sensitive to how quickly Temporal responds to requests to start a workflow, for example, or how long it is between requesting a workflow to be started and actually starting on a worker. So these kind of latencies that will partly depend on the speed of the database, because we can't, even if our networking speed was instant, which obviously it never will be, the database is still going to take some amount of time to acknowledge these things. So we need to be kind of aware of the different latencies that we should expect for different database backends to sort of tailor open source users' clusters to meet their own requirements. But also it's trying to avoid people getting into a position where they've deployed the temporal cluster and they're growing, which hopefully all the use cases are, and they're in a position where they can't easily upgrade because the shard count can't be adjusted. And the shard count works as like a maximum throughput in a way. Now we're working on things like migration to allow people to build a new cluster and migrate traffic over. But those tools aren't 100% yet, and they take some doing. They don't come for free, as it were. I don't mean cost-wise. I mean in terms of like learning them and configuring them and setting them up. So it's trying to give people the knowledge to correctly size a cluster to handle the workload they need, and also to help them evaluate it against things like Temporal Cloud. It's always going to be trade-offs. So generally, Temporal Cloud will come out cheaper because we've got the economies of scale and the expertise to run things at the back end. But there's people aren't always going to want to do that. They want to run the stuff themselves. So it's giving them more knowledge to make decisions on sizing of clusters and costs.
Okay. You mentioned history shards. So that's like an application level concept in the history service, the service that stores in a workflow's event history. And it's a static parameter that you set when you build a cluster. What's like the range of typical values or possible values?
So to some value of normal clusters that we never see production clusters with less than 5 shards. So that's kind of the smallest end, just because the cost of each shard is not high enough that it's worth going. The normal range, I would say, is probably between 1,000 and 4,000 shards. 4,000 can handle a reasonable amount of traffic. We do see, for example, we've had users on Slack recently talking about they've installed 25,000 shards, but that's definitely an outlier. I think that's really quite a big cluster. So yeah, the normal range we'd see in self-hosted deployments is between 1,000 and 4,000. And 4,000 can handle, it's all subjective without numbers, but that's a big cluster. That's a reasonable amount of traffic. It's quite heavy work.
Is there sort of like a sense of max shards per pod you'd want? So like, is the 25,000 example have 25 pods each with 1,000 shards per?
So we generally recommend 512 shards per history pod as the maximum, but it will depend a lot on what your workload is as to how much you can get away with, and also how many resources you're allowed to give each pod or happy to give each pod. So we aim for 512. One of the issues is that because of the algorithm we use to try and keep history shards on a given pod, if others go down and come back because of caching, the balance between the pods in terms of number of shards is not even. So normally you'll see some pods will have twice the number of shards that other pods do, just because of, like I say, the algorithm we use to try and keep shard on a pod as long as we can. So if you're setting the sort of, if you're only having enough pods that it's going to be about 1,000 shards per pod, if it was even, then you can have up to 2,000 shards essentially on a given pod, which starts to be sort of quite CPU intensive. So it's all trade-offs. We give you sort of recommendations for like the average use case, which would be aiming for like 512, and then see how you go. If you find that you're still not using much RAM because your workload histories are on average are very short, for example, or you're not using much CPU because your workload is fairly light, then you can pack it harder. It's kind of experimentation. So we give you suggestions in our blog posts and reference documentation about like metrics to look at to make these decisions. The like aim for 512, 500, and then I think the user who had 25,000 shards was running 500 shards, 50 history pods. So it's that's a lot of processing power. It's quite a big cluster.
Okay. You also mentioned state transitions. What's a state transition?
So a state transition is it's a metric, and we emit the metric, so we increment the metric every time Temporal has to write to persistence. So basically, every time we provide you some value in terms of making executions more durable and basically recording the current state of things will increment this state transition metric. So a good measure of throughput, as opposed to latency, is state transitions per second. And that's the measure of how many things we're able to successfully record to the persistence every second. And so, whereas things like number of workflow completions per second would vary hugely based on how long the workload takes and how many workers you've got and all these kind of things, the state transitions is a sort of purer measure of throughput, because it doesn't matter what the workload is or what the workflows are doing, they'll all need to generate state transitions. And you can write really evil workflows which basically do nothing but just cause lots of events to happen in temporal, so that it pushes the state transition. It's a sort of pathological case, so that you don't have to spend much on CPU for workers and stuff in order to test temporal's core performance. So yeah, if you're trying to test performance of a specific workload, then you probably focus more on number of workloads you're able to start per second and sort of more things specific to your workload. But state transitions is a really useful abstract measure of throughput. It's a bit like I/O per second rates on databases. It's a similar kind of measure for throughput.
Okay. Is that just writes to history, or you said it's all writes to persistence? So it's also mutable state, also matching?
So mutable state is actually part of the history service. So while we do write all of the history events themselves get written to persistence by history, history is also responsible for the mutable state. So that would be things that don't necessarily get written to the event history directly, like activities that are currently pending, activities that are retrying, that kind of thing. And matching does write to persistence as well, but I don't think we count those as state transitions because that's kind of task management, Temporal's internal system, as opposed to sort of direct value providing stuff that the history service produces. I don't know for sure, actually, it's a great question, but I believe that the matching stuff is not included in state transitions.
Okay, so that would be only history service, both to the event history and mutable state.
Yeah.
So you just gave a talk at Replay on performance testing temporal. And I want to see if I got the summary right, and you can correct me. When I do a performance test, first I set up a cluster, then I put load on the cluster, and then I measure latency and metrics. And then depending on which of those measurements is not where I want it to be, then I scale. So that's the load, measure, scale loop. Then I repeat back to that, putting load back on it. Okay.
Yeah. Also, it tends to be the case that when you scale stuff out, you can take more throughput, and so you need to remeasure to check if you're now sort of overusing CPU on some pods that you weren't before because you're letting more tasks through. So it tends to be you add load and then you do the measure and scale thing in a loop, as like an inner loop, until everything's stable.
Okay. And then I'm doing the load and measuring multiple times and then averaging them because even if this cluster is the same size, if I run the load multiple times, I might get different measurements.
Yeah, part of the reason for that is the load balancing that we were talking about, where we balance shards across the history service, and the same is true of task queue partitions across matching. Every time you bring up a cluster, that's going to work slightly differently depending on when the pods come up and that kind of thing. So the balance will be slightly different. So that and entropy in general of internet systems, you will find that the values will vary slightly every time. So it's important to run to make sure that directionally you're getting a reliable result in the direction that you want.
Okay, and then repeatable means like putting my load tests and my cluster config in code in Git.
Yeah, it's very important to be able to produce the benchmark repeatedly, reliably, because if you have to manually do any step, there's so much scope for accidentally changing, forgetting to change the word count or some other value that you rely on, and then having really weird results because you didn't actually run the same thing twice. So yeah, that's the reason for making sure that everything is repeatable in a sort of automated fashion.
Okay. then see measurements results should be state transitions or application relevant metrics. Okay, we talked about that. Set SLO, service level objective, for your business requirements on latency. So if I want to be able to start a workflow within 200 milliseconds, I'd set that as my SLO, and then in my Grafana graph, I could see when the latency metric for start workflow went below that line of 200 milliseconds.
Yeah, and if you can, yeah, and if it does spike above that, then you consider the benchmark failure, or you go back into the scale measure loop until you get it back down and stable, and then you go from there.
Okay. And for scaling, our options are adding processes or cores to spread CPU. Watch out for CPU throttling. What's that?
So CPU throttling is something that happens when Kubernetes decide. Well, normally it's Kubernetes or Docker, depending on what infrastructure you're using. I'm sure other tools will also have similar concepts, but it's if sort of whatever orchestrator, sort of container orchestrator you're using decides that you've used too much CPU, it will throttle your process on the CPU for a little while until you've got sort of build credits back up effectively. And the reason I call this out specifically is a lot of people assume that if their CPU usage is below 100%, that they won't be throttling. Unfortunately, it's more complicated than that, and you often are throttled because the time slice that's used for deciding what CPU percentage you're using and the time slice that's used for whether you should be throttled or not are very different. The time slice for throttling is very small. So if you burst on the CPU for milliseconds, you can still be throttled, even though your overall CPU usage for the second, for example, is 50%. So it's very important to check for CPU throttling. And we've got a blog post which is linked to that, which helps you dig into this and some suggestions as to how to reduce CPU throttling when you're using Golang-based apps, which Temporal is.
Cool. And then the third point of scaling was max shard count cannot be changed, which we talk about. That's the history application level shards.
Yeah.
This performance testing temporal talk will be on YouTube. The first like 3 keynotes of replay will be coming out soon, and then I think the rest will be released later on. So this was my notes for what Rob has done. So in addition to that talk we just mentioned, there's a couple of blog posts, scaling temporal to basics and tuning latency on Kubernetes. And then for cluster building, sort of like sizing, like choosing which database and sizing how many pods, and you recommend using Terraform or Pulumi. Could you talk about what trade-offs, or like which of those I should use?
That's very subjective and possibly religious. So they're just different approaches to do the same thing. So Terraform is taught by HashiCorp, which is an infrastructure building tool, and Pulumi is a very similar thing. It's just by a different company. One is the Terraform is imperative, is that the right word? Language, HCL, I think it's called. Whereas Pulumi, you write code, which does the infrastructure building. So it's just like different approaches. I don't think one's better than the other. Pulumi comes more naturally to me, but either is equally good. And there are lots of other tools that do similar things, but these are the sort of 2 most popular, I would say. There's an example of a Pulumi-based tool in this repo that you're just tweeting out. All of this is open for people to play around with.
So you made this repo temporal.io/benchmark matrix, and it has different Pulumi configuration files.
Yeah, they're called stacks in Pulumi. And each one of these stacks is a configuration for a specific test run. So I can throw any of these stacks in Pulumi and it will build a cluster. All of this stuff is currently only implemented for AWS and EKS. But it could, Pulumi supports Google and Azure and all the big providers. So I just haven't done that work. It would be easy to do. So yeah, it's the entire setup for the cluster and temporal and the load test is all included in this one file. So it allows you to repeat benchmark tests very easily.
Okay, so let's see. Here's the benchmarking part, where here are the application workers and how many pods they have and how many pullers they have. And then this is the client that is starting this many concurrent workflows.
That's correct.
Pods. And then let's see, EKS persistence for using RDS of a certain size, 16x large. And then here is the cluster configuration, like the front end service has this many pods, history service, matching, internal worker. Okay, cool. So that's benchmark matrix. Then benchmark workers for doing the load generation. You used to use we used to have a repo called XK6, which is for benchmarking, which is now archived. What was the change there?
So the reason, firstly, the kind of load generation I used to do was very, very simple. Benchmark workers is tiny, and using K6 is, you know, it's easy, but still there's quite a lot to learn. Whereas, in terms of writing scenarios and that kind of thing, whereas for the very simple case where you're just thrashing temporal as hard as you can and you don't really care how, benchmark workers was much easier to manage and reason about. So there is actually another tool called OMES, which is written by Rory and Chad, which does more K6 style stuff, but specific to temporal. It does support things like scenarios where you've got you want clients to do sort of start a workflow and then signal it and then query it, for example, and that kind of more complex interaction. Whereas benchmark workers is more, I want a workflow which just launches 3 activities which immediately return after doing nothing. It's just a way of generating temporal events very cheaply, basically, in terms of load testing. So that's why I ended up using benchmark workers. And then Rory and Chad wrote OMES. I'm not sure if that's how you pronounce it, OMES, to handle more complex cases using what they call the kitchen sink workflow, which is like a pluggable dynamic workflow which you can create as many activities you want and wire them up in different ways and stuff. So that would be more sort of specific workload simulation in a way, if you didn't want to use your own code or hadn't written the code yet. Whereas benchmark work is just like, how hard can I push this to cluster at a sort of throughput level?
Okay. Any questions for Rob from the audience? We also have the Codex server docs for people who are interested in that piece. Talks about the API contract of like what the web UI or the CLI calls on the HTTP endpoint of the Codex server. All right. Well, thank you so much, Rob, for sharing.
Yeah, no worries. Let's talk to you.
Next up, we have Replay Recap. So, Replay is the annual conference hosted by Temporal and dedicated to the platform's practices and trends in software engineering. It was a couple of weeks ago. Many of us from Temporal went and had a great time. It was 3 days. So the first day was workshops. We had 3 different languages, Go, Java, and TypeScript, with all day Temporal 101 and 102 courses. And then day 1 and day 2, we had 3 tracks of technical talks. For the first day, day 0, I had some photos. Here's the TypeScript 102 room. And then this is Tom Wheeler doing Temporal 102 and Go. And then the Java course. And then on day 1, Maxime started out with a keynote on durable execution, the way forward for event-driven architecture. So I asked ChatGPT what event-driven architecture is, and it says it's a a software paradigm where components interact through events. Events are generated by event producers, routed through an event bus, and handled by event consumers. So this is a common practice in backend engineering or distributed systems, often used with like microservice choreography, where instead of one service calling another directly or synchronously, you put an event on a bus like Kafka, and other services subscribe to that event. So if I did like if I had Amazon.com and someone submitted an order, then that first service that like the API gateway sort of forwarded the request to for like submit the order might have done something in a database and then send a order created event to the bus. And then there were other things that might respond to that order created event, like, oh, I need to do a payment now. And so the payment service will pick up that event and try to do the payment and then put another event on the bus that's like, okay, payment succeeded. And then at which point the fulfillment service will pick up a payment completed event and then say, okay, now I need to do the fulfillment, etc. So then ChatGPT goes on to say EDA is particularly effective for systems requiring loose coupling, scalability, and real-time processing. So Maxime's argument was that the kind of loose coupling that EDA has is at runtime. So if like the fulfillment service goes down, that's okay in this choreography world, because when the payment service emits the payment completed event, it's okay that the history service, or sorry, the fulfillment service isn't currently available. It'll just stay on the bus until the service comes back up and the consumer picks up those events. So they're so I guess the decoupling at runtime is that any of the individual services doesn't need to be up at that moment to receive that request. But a very important aspect of coupling, and one that's probably more often used, is the coupling of at design time, at time of coding. And typical conventional event-driven architecture like choreography is very coupled at implementation time or design time. For instance, if I change the like type of an event, I need to, or change some of the data that it has in a breaking way, I need to find all of the other services in my company that respond to that event. And that could be like by searching through all of the code bases at my company to try to find that keyword or something, to see if I need to update them. And then I have to figure out how to change all of those code bases and get them deployed in the right way, such that they'll be able to handle it when I change the event that I emit. I guess if you have like distributed tracing set up, then you might be able to like look through all of the past traces to see what are all the services that consume this event, in which case that might be easier than searching through all the code. But either way, you need to make this change sort of lockstep with everyone else in the company, which is coupled. So Maxime's argument is basically that you want not only runtime loose coupling, but also design and implementation time loose coupling. And in order to get that, you can use durable execution or temporal workflows. Because instead of trying to figure out what's happening in the system and who's responding to events based on like tracing or searching through code, you can read the workflow function and see what it does, which is a much easier thing to look at, see, understand, and change. particularly with the visibility you get with our event history and UI. So I think ChatGPT is wrong about the benefits of being scalability, easy to add, remove components. I don't think it is. Flexibility, components can evolve independently. You can deploy them independently. You have to change them dependently. Like responsiveness enables real-time and asynchronous processing. Sure. Limitations, complexity, event tracing and debugging can be challenging. Yes. Consistency, handling transactional integrity is non-trivial. Also, yes. So, like, in order to do transactions between like your local services database and the event bus, you have to use a transfer queue every time you're sending an event. So you have to, in a transaction, write to your own database both the change you're making and like a mini local queue with that event, and then you have to have another thread running that's picking things off of that local queue and then putting them on the event bus and deduplicating and stuff. So every time you need to publish, you need to use a transfer queue or a transactional outbox, which oftentimes doesn't happen, and is a lot to manage and maintain, and that's something that you don't need to do at all with Temporal. This is one of my favorite slides from Maxime's talk, where we have a dating app, and the people that aren't a match are applications where the hobbies are inconsistency or failing requests to the caller, and they're like losing data or not completing tasks. So the argument is that, like, if I don't need to finish if it's fine for me to, when I received a request from like a user or a client, if it's fine for me to return like, sorry, I failed, and I don't need to do any compensation, then I don't need to use Temporal. I can just have the user click the button again. But I probably most applications you care about consistency and eventually succeeding on things rather than making the user retry. Then another one that we're not a match for is log event shipping or stream analytics. And then we get a match with state management, guaranteed completion, compensations, and uniqueness. I'd say, like, more broadly, anything that's not these two categories. After Max, Samer and came up with Preeti, our new SVP of engineering, to talk about some new features, both in the Temporal platform and in the cloud product. One of those is contributed by Datadog, who made a Temporal integration for open source servers, open source Temporal servers, with like an automatic dashboard with different metrics. And they also contributed a tracing integration to the Go SDK. And here's an example of that, where you can see a flame graph of temporal.run workflow in the middle, with the workflow type is a Slack send message. Then within that workflow, there's an activity running, that's Slack service update message. And within that, there's an HTTP request. So you can see the tracing, you can see the logs, you can see the total time that the workflow took on the top left, 9 hours and 59 minutes. You can also like filter based on how long a workflow took and other things. Here's a long list of things we've built recently. And one of the big things is called workflow update. So before we had this, your app has to, in order to communicate with an existing workflow execution, you have to signal it, and then in order to figure out like what the new state is after the signal or what the result of the signal is, you have to query polling query until that update has happened, or you could signal the workflow execution. The workflow execution like schedules an activity, and you run your own activity worker inside your app. And that's a way of like getting notified that the signal was handled. So after that, now, at least in the Go SDK and another SDKs coming soon, you can send an update, and an update has an argument, like a method name, a type. Arguments is able to mutate state in the workflow, like change value of local variables, and also can return something. So it simplifies the pattern, and it also allows for lower latency use cases. Another big update is to our cloud service. We have been putting a lot of work into global namespaces, which means that so previous to this, so current default is that when you sign up for a cloud temporal cluster, you choose a single region that it lives in. So if that region goes down, then you're unable to make progress on your workflows, and unable to start new ones. Which limits your availability, and we only have an SLA for 3 nines due to that fact. And global namespaces allows you to configure a backup or failover region. So if my primary could be in, let's say, US West, if that region goes down or unreachable, it fails over to US East, and everything continues from where it left off. And that's a big engineering feat, to be like continuously asynchronously replicating all of your workflow state to a different region. So talk to your cloud contact or open a support ticket if you're interested in being one of the first people to turn that on. More things that happened at the conference. I did a tweet thread with some of the talks that I went to. The first day, Sai Pragna from Twilio talked about how Temporal allows them to develop faster and scale their engineering teams. Sort of the impact of Temporal was changing our thought process from everything before was like a state machine and state transitions. They had to think about everything in that terms. So now they get to think about of things in terms of a simple sequence of steps, which is easier, just mental load. So smaller learning curve. Teams loved it and adopted it in every new initiative. Very fast. Have seen entire end-to-end workflows migrated to Temporal, and it's helped them scale their engineering teams better. There were birds of feather sessions with some SDK engineers. In this one, Quinn and Chad, who maintain the Go SDK, talked about what's coming. Worker auto tuning, so having workers dynamically and automatically adjust worker parameters to get the most performance out of a worker. Improvements to the static analyzer to make sure that you can catch non-deterministic code. And they'll also be providing a sample showing how Go generics can be used. There's also one for Java with Quinn and Tiho, and they talked about similar auto tuning and static analyzer, but also expanded Spring Boot features coming up and support for Java virtual threads. And this was Ryland giving a talk on how we use AI. I highly recommend it whenever it comes out. It was a lot of fun. We're doing a POC on doing an LLM-based determinism checker, and we also have iq.temporal.io for an LLM-based search tool. This is Mark and Max from Afterpay talking about how they use Temporal for real-time payments. This is the close out of the first night. Then we also had a talk from Eric Johnson about challenges. One from Chris from Azure about how Azure durable functions brought durable execution to serverless. And he also POC'd running a temporal.sdk on Azure functions. Here's the durable execution family tree with the Azure over in the middle and then Temporal on the bottom right, and then added recent new different ones with Infinitec and Restate. And they have billions of executions a day on Azure durable functions and used by 65% of the top 500 enterprise function as a service customers. One of my favorite talks was Paul Nordstrom talking about CDS, which is our cloud data store. So a custom persistence layer for Temporal server built to improve the reliability, scalability, and latency of Temporal Cloud. And also, as Rob said earlier, improves the cost that we're able to be provided at. We had Dan Norris from Cosmonic talk about how they use Temporal to host your backend WASM, which is the Cosmonic startup, what they do. And he said Temporal's programming model is perfect for managing infrastructure. Grant from Datadog talked about the large payload service that they released, which sort of seamlessly allows you to send payloads that are larger than 2 megabytes, which is the current platform limit. And the way it does that is it has a data converter that talks to a service that uploads things to a blob store like S3 for you seamlessly, and then like reloads it back when decoding. So basically, translates your big argument that's over 2 megabytes into this URL on the, and that's what goes over the wire and gets saved in history. And then when you're decoding it, it gets looked up in the blob store. Here we have Tiho talking about how to diagnose common issues folks run into with worker tuning options and scaling. We had a panel with Rob from Netflix and Jacob from Datadog. And Datadog shared that they have 1,000 engineers starting workflows and a few hundred workflow developers and worker deployments. This is Rob's talk, Performance Testing Temporal, and After Party. And that's all I have. Any questions about replay? Awesome. Well, I will see everyone next month on October 31st. This is, again, the last Tuesday of the month, 9 a.m. Pacific and noon Eastern. See ya.